revealing secrets of the Earth and stars.
This will be the hottest place in the universe.
And blurring lines between minds and machines.
Wow. That is impressive.
Irish scientists have their fingers on the pulse.
This week on 10 Things to Know About, we're all about drones. Kathriona finds out how the Defence Forces are using drones to protect Irish peacekeepers abroad.
Whoa!
Eoin meets the search and rescue volunteers who are developing drone technologies to help save lives. And I try out the increasingly popular sport of FPV drone racing and try not to crash and burn.
I do feel bad.
Drones, or unmanned aerial vehicles, are all the rage these days. The technology was originally developed for the battlefield, but it's become so versatile that for many, it's become as simple as child's play.
First-person view, or FPV, drone racing is a motorsport where pilots race small radio-controlled drones around a track. The drones are equipped with cameras and the pilots wear goggles that display the live stream feed. FPV racing began as an amateur sport in Australia in 2014, but its popularity has exploded, with pilots competing at race events throughout the world. Keith Tracy is a drone enthusiast.
Keith, this is sort of the bringing together of two rapidly emerging technologies, right? It's drones and virtual reality coming together.
Yeah, I suppose you could call it virtual reality. So if we look at a drone here, so here's an example of a racing drone.
It's small.
Yes, tiny, yeah. You're talking in and around 400 grams.
Wow.
But if we see here, it's a very small camera on the front, and that small camera feeds back to these video goggles, which some people would kind of compare to virtual reality. This is reality. There's nothing virtual about it. Certainly when you're heading towards a wall at 100 kilometers an hour. But yeah, you can
100 kilometers an hour?
Yeah, easily, yeah.
Wow.
Yeah, even faster.
I'd really like to try this. Can you help me try this out?
I think we can make that happen, absolutely. Fantastic, let's do this.
All right.
I'm excited. Little bit of throttle and have your finger on the other stick ready to engage. Too much. Catch it.
Whoa.
Relax, nice and slow. And let's bring it in for a land. So let's bring it in for land. So less throttle, less throttle, less throttle.
Okay, I'm trying.
Relax, 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 relax.
Why is it so far away? Oh no. What?
Your first crash.
What happened? We lost the drone.
She went? Yeah, she's gone. She's gone. We've lost her.
But I didn't do anything.
Correct.
Oh man.
Let's go find it. It's okay. It's landed safely.
I better be going.
Of course, it's not all fun and games. There's a far more serious side to this technology. I'm meeting Captain Eoin Murphy from the Irish Defence Forces, who are using drones to protect the lives of Irish soldiers.
The main purpose of drones was to allow the people who wanted to use them to get information in areas that were considered too dangerous maybe to send in manned aircraft.
And they're not drones to you, they're unmanned aerial vehicles.
They are, yeah. UAVs is what we call them. You hear a number of terms, but we just stick with UAV.
And say, for instance, if you're on a mission in Chad, how would you use it?
Primarily, it's for what we call over-the-hill technologies. So in Chad, what they used to do was stop before they got to a choke point in a road or some sort of village if they were unsure if it was containing guerrilla fighters or whatever. And the UAV would fly over the village and provide an aerial perspective and allow people to look behind walls, into gardens, on roofs and see was there anybody with hostile intent in the village before any of the soldiers got exposed to that threat. This is the plane, if you like, or the drone, or the UAV, whatever you want to call it. There's a parachute and an airbag in it for its landing.
Oh, no way, it lands by parachute?
Vertically onto the ground, yeah. This is your payload, or your camera. It's a split camera, so you have the thermal imager on one side and you have the day camera
Okay, yeah.
on the other. Our antenna here, our shark fin antenna, is for the up and down transmission to these antennae, which are for the ground.
Right. And like the drones that we might be familiar with, you don't just throw it up in the air, you have to launch it off.
Yeah, you do.
Okay, let's get it up in the air. Can I press the button?
No.
Launching. 3.
Whoa, that is impressive.
This Orbiter 2B drone flies at a much higher altitude than regular drones, around 1,000 feet. Advanced technology allows the drone to automatically switch transmission frequencies if the signal between the controller and the drone becomes blocked for any reason, such as extreme weather conditions, interference from other aircraft, or third-party sabotage.
The UAV and the radio frequency box must be able to talk to each other. It's like when you sync your television to your skybox. It's all about having them on the same wavelength. If we have a certain frequency that then gets jammed and we have the inability then to fly, we just go to hopping frequency and it picks a random frequency preset by us and it hops every 20th of a second to each one to allow it to still communicate at random.
It just looks like a big bird.
Yeah,
Like it's very discreet.
it is discreet. So at the moment it's not even at 1,000 feet and you already can't really hear it.
Yeah, yeah. Oh, there goes the parachute.
So there's the parachute out.
It'll come as no surprise that operating this UAV is a little bit more complicated than controlling a standard drone. Defence Force operators are required to undergo 6 weeks of simulation training before they're allowed to try the real thing. But Captain Murphy has kindly offered to give me a quick crash course. Let's hope not literally.
The scenario that we have at the moment is that the Navy have blocked off a port. They expect to be conducting a search of the port for contraband, and they have a vessel that's acting suspiciously that they want us to go and check out. So, ready to go. 3, 2, 1, launch. On the left-hand side of your screen, you can see where the UAV is in relation to your map. And then on the right-hand side, you'll see what it sees in real time. So at the moment, we're in loiter speed.
Loiter, that's my normal speed.
Your
That's
favourite.
quite suits me. We should go max though, I think.
We should go max. 50 knots, which is about 93 kilometres an hour.
Okay, pretty fast.
Yep.
Oh, look, and there's the ships.
There's the two ships. What I want you to do now is follow the boat, because the boat is going to start to move.
Okay, I can do that.
Okay? And make sure you don't lose it.
Okay. I'm on it. Oh, no, I'm not. Go, go, go. It's gone.
It's there somewhere.
Come back. Oh, no, I've lost you.
Okay, and to make it easier for yourself,
Oh, I should zoom out.
simply zoom out.
Yes,
Yeah.
yes, of course. I knew it was going to be difficult, but it's just a little bit.
Don't say it's too difficult.
It's not difficult. It's just you need to use both hands and your head at the same time, which I'm not very good at.
Yeah. This little mission flew 10 kilometres from where we launched to a port and covered a huge expanse of sea in less than 10 minutes. If you were to do that on the ground, you're talking about a couple of hundred people, lots of vehicles getting through the city to the port and then looking from the land outwards. So the ability of these to cover huge swaths of area very, very quickly and very efficiently makes it an invaluable asset for us.
How are things going to evolve into the future, do you think?
I suppose it would be like all technology that's kind of commercially available. You're talking about things getting smaller, battery life's improving, range is improving. You know, in terms of how the system operates internally, the size of components, it'll all shrink down and become...
You'll be taking it out of your pocket there. And
Yeah, just launching it off my hand.
Drones are frequently used to film spectacular aerial scenery, sports events, and concerts. But there are also increasing reports of near misses with aircraft and concerns over privacy and security. Ralph James is with the Irish Aviation Authority.
There are regulations for the use of drones, and that says basically know what you're operating, stay away from certain places, don't overfly crowds, especially stay away from airports, because obviously they are a danger. But there's a lot of positives that drones can bring. They're being used in agriculture to enhance crop outputs or crop delivers. They are being used for oil rig inspection, so it saves dangerous work where people are doing now. You can replace it with a drone with proper scanners.
In terms of security, could drones be used by terrorists, for example?
Any equipment can be misused by anybody who so desires. But companies are working to develop technologies which will counter drones. We have the example in Holland where they have trained birds of prey to take down drones which are flying in areas they shouldn't be flying. We have technologies being developed to take electronic control of drones to bring them into land. We also have geofencing being developed, which will be a bubble that will spread up around an area to stop drones inadvertently flying in or out of a particular area, depending on how it's applied.
Do you foresee a case where having a drone will be like having a mobile phone? We'll have drones flying around everywhere.
I read a report recently that said every house will have 3 drones in it very shortly. One to do the shopping, one to keep an eye on it, and one to walk the dog. The technology ultimately will go as far as our imaginations can take us in many ways. But if you use as an example, later on this year in Dubai, a person carrying drone will go on test. So you simply step into the drone, there's one seat, you strap in, and you select from 6 destinations, and the drone will take you to that destination.
Wow, so there's actually lots to look forward to in terms of drone technology.
The world is your oyster, Ian.
Any wannabe superhero worth their salt has a few defining characteristics. Immense strength, quick healing, and of course, X-ray vision. But it turns out that the ability to see through walls doesn't need a caped crusader, or even X-rays. In fact, all you need is a couple of drones. Researchers are developing a way of making the invisible visible by marrying the mapping ability of drones with something that is now found almost everywhere: Wi-Fi. This revealing research starts off with 2 standard drones. On one, you put a Wi-Fi transmitter, and on the other, you put a Wi-Fi receiver. As the transmitting drone flies back and forth along the wall, the Wi-Fi signal is transmitted through the wall, being bounced by the hidden structures behind. These bounces change the strength of the Wi-Fi signal received by the other drone. And by approaching from different angles, these small changes are converted into a 3D map of the uncharted territory. What's more, Wi-Fi can also be used to track the movement of people behind walls, and is even capable of detecting whether a person is alive or dead, simply by the change in signal due to the rise and fall of their lungs. With uses in crime fighting and search and rescue, along with putting superheroes out of business, drones are now bringing see-through vision to an ever more complicated world. See you next time.
Wi-Fi is used in almost everything these days, from phones to baby monitors to drones. The problem is that there's only a finite amount of radio frequencies available for mobile devices, and we're starting to run out of space. Evan O'Keefe is researching solutions to this problem.
Your work is in trying to free up the traffic and flow of information. How are you approaching it?
What we can do is that we can tell the devices to essentially use the resources that they have much more intelligently. So that's to say, we've got a certain selection of the frequency that you can use. At the moment, everyone's just using that single little portion. Imagine the analogy where you've got 10 people at a bar and they want to talk to each other. So you've essentially got one frequency and you've got 10 people wanting to use that space.
If everybody's talking together, it makes no sense.
Yeah, exactly. Versus if you have the 10 people split off into, say, 5 different groups, where they've got an equal amount of spacing between each other and they can hear each other.
And that way you're using much less of the frequency and much cleaner communication.
Exactly.
To enable the drone to do this, Evan is using technology called software-defined radio, which allows new wireless features and capabilities to be added to drones without the need to change any of the hardware inside.
Let's just say you want to upgrade all of your drones because a new security update has come out. Traditionally, you would have to actually physically replace the actual drones themselves because everything's built in. With my method, you would have fairly generic radio systems, and then it's the software that actually becomes the brain for it. And once that's in, you can just write up a new one and write up another one and just upload it.
This isn't just fun with toys or a university project, is it? There's real-world applications of this technology.
Yes, the main application that we're really going for here is search and rescue operations.
Evan is looking to integrate software-defined radio technology into a multiple drone platform that can be used to create a temporary aerial telephone network in post-disaster scenarios, such as after earthquakes or in severe flooding. He's working with the Irish Red Cross and using Bandon in County Cork as a case study for how SDR drones could assist towns prone to flooding.
We can actually support up to about 10 different calls per drone, which is great for the power that it takes up.
And how many drones would you network together in a hypothetical disaster scenario?
We're hoping for hundreds.
Really?
Yes.
Wow. Imagine that in the sky.
It would be something, but at the same time, those hundreds will be distributed over kilometers, so they'll cover a very wide area.
All of these drones need to have exactly the same hardware, or can one drone made by one manufacturer speak to another made by another?
With the new technology that we're building, it will be generic, so every manufacturer should be able to talk to each other. Once the drones are up and flying, your phone will automatically connect to it, the same way that it will do with normal base towers.
Okay, so for the end user in a disaster zone with no mobile masts working, they won't notice any different. It'll just seem like their network is available.
Exactly.
Clever. And so what stage are you at now?
At the moment, we have the actual radio systems on the drones working. We're now working with the IAA and with the drone regulations to actually get them to give us permissions to actually fly these over urban areas.
Ireland is blessed with some of the finest scenic walks in Europe. But hills and mountains can be dangerous places where even the most experienced climber can be caught out. In 2009, mountaineer Keith MacDonald and a friend were climbing Lugnaquilla in County Wicklow when they became stranded due to sudden extreme weather. They realised they'd have to stay on the mountain overnight in freezing conditions and used their mobile phone to raise the alarm with mountain rescue.
They didn't know our location, like we didn't know our location. So it was quite a large area at the top of Lugnaquilla. We would have sent different teams. Most of the teams from Ireland and the PSNI up the north, the Army were involved as well, and the RAF from the Ogwen Valley over in Wales. We were rescued, would have been the following day, early afternoon, if I remember correctly. So we would have been on the mountain probably 28 hours at this stage.
There are 11 mountain rescue teams across Ireland, providing a vital first responder service that's maintained entirely through the commitments of dedicated volunteers.
Mountain rescue teams play a hugely important role in keeping our walkers safe. And here in Donegal, the local rescue team have been quick to adopt drone technology to help save lives.
Oisín McGrath is co-founder of DroneSAR, a company which has developed unique software that could revolutionise search and rescue missions across the world.
Oisín, can you tell me where the DroneSAR technology came from? How did you come up with the idea?
Yeah, so originally Leo, who was team leader in Donegal Mountain Rescue, felt there was a need for drone technology and that the current software applications that existed weren't really fit for purpose. So at the time, Matthew was volunteering with Donegal Mountain Rescue. Matthew is an award-winning app designer. And then we brought in Grode O'Brien as well. And myself and Grode have a background in aviation.
So you have the pilots, you have the software engineers, and you have the mountain rescue all coming together to develop this application.
Exactly, yeah. So uniquely, we didn't have to go looking for anybody in particular. Our skills just matched, and the blocks just kind of fit in, the pieces just fit together very nicely. So DroneSAR, at its basic level, allows a pilot or an operator to very quickly select waypoints if he wants to fly a line mission or a search pattern. He can drag the side of the grid to make it whatever shape he likes. And once he chooses the altitude, the grid will be filled automatically with the drone software. All he has to do is press fly and the drone will take off, and once he keeps visual with the drone, it'll fly automatically. While all that is happening, he can stream the data back to the command and control unit, which mightn't necessarily be within range for the drone itself to connect, but it happens over a mobile network.
So I can focus on if I can see the person that I'm looking for, or if I can track the team, and I don't have to worry as much about driving the drone.
Yeah, exactly.
Oisín has developed the technology with Leo Murray, Deputy Lead Coordinator of Donegal Mountain Rescue.
So, Eoin, this is a typical scenario. We get a call from the guards and they have some information regarding a person who's been out all night. So there's a lake down here that we want to look at in particular, and it just starts the access point into it. It's just down here along the edge of the forest here. Okay. We've actually positioned the blue bag, and that's going to be our hypothetical person.
So, you've a rough idea of where you're going?
Yep.
Can I stay with you and keep track?
Yeah, absolutely. I'll show you the process and you can see how Matthew works in advance of it.
Great. Best of luck, lads.
As part of the simulation, Matthew enters the route for the drone to follow and sends it off to search for our blue bag.
So, Leah, this is amazing actually, because we can see what the drone is seeing and we're also getting its flight path tracked in real time.
That's right, Eoin. And by clicking on the drone as well, we should get GPS location, its coordinates, its altitude, the speed that it's flying. We're in a mobile control unit, but that same imagery, that same link could be viewed by somebody in Dublin, it could be viewed by somebody in New York. You know, once they have linked and access to that, that means that you have many eyes looking at the situation. So we could have not alone just 2 search managers, but we could have 22 or 2002. And if we miss something, we could get a call saying, I picked something up. The imagery that we're getting back, you can just see it there actually, he's located.
Yeah, that looks like our blue marker.
Yeah. Ergal base to Ergal Charlie, over.
Over Ergal Charlie.
Roger that, Charlie. If you can make your way towards grid reference G955 855, repeat G955 855, over.
Message received and understood, over. We're on site now with the casualty and we are just securing the perimeter and doing a gear dump. Over.
Roger that, stand by, over.
So the drone technology, the app that we're using, it's really making this whole process efficient.
Absolutely, but I have to say, if anything, it's reducing the element of risk because there is a lot of risk involved in what we do. The nature of the type of service we provide is that from time team members would have to be put into compromising positions. So that's maybe going over to an edge of a cliff or having to get in to an area to assess it. And with drone technology in the drone, you're able to get in there fairly quickly and send back good live, crystal clear imagery without having to set up ropes and putting somebody into that position. Yeah.
This uniquely Irish software is attracting huge interest from groups all over the world, and applications could go far beyond mountain rescue.
And then the next level for us is bringing in kind of a satellite integration, which will allow data transfer in areas where there's low network connectivity, low mobile network signal, and we're working with the European Space Agency to develop that in. So we'll become a very dominant force, I think, in the rescue scene, not just search and rescue, but all the emergency response.
So you're still all working at your regular jobs, but growing this into a really big technology product coming from Ireland.
Yeah, and it's taken a lot of time. It's not easy. The startups are difficult and frustrating at times, and it's hard going, but every hour we have, we use.
That's our 10 things to know about drones. For more information on all the episodes and topics we've covered in this series, check out the website 10thingstoKnowAbout.ie.